Today I am going to explain you ACID properties. ACID properties actually belongs to the transactions and the transaction belongs to the SQL server. Before understanding about ACID properties, it is good to know about the transaction. Okay, so let's begin. The transaction in RDMS is a set of logical operations performed to access and modify the content of the database. Any data storage system which follows ACID properties known as transactional system. Okay, the way how the transactions or how the set of queries is performing their task in our database are below. This is the diagram which show you how our database, how our queries is working in our database. First, initially, our original data will be there in our database. We have to create a transaction, we have to create the queries and begin it first. Okay, this transaction have numbers of queries which needs to be performed one by one. If all the queries perform correctly, the result is pass, then data will update in our database. If any one of them fails, then it will roll back and data will save as initial state. Okay, so this is the characteristic of our transaction in RDMS. So the transaction must have to pass this ACID property. Okay, let's see what is the ACID. ACID actually it is a four key properties that define a transaction. It guarantees that each read, write or modification process of a table has below properties: atomicity, consistency, isolation, durability. Any data storage system which follows ACID property known as transactional system means the transactional system must have to uh, follow all these four properties. Okay, let's check first of them, atomicity. Atomicity ensures that a transaction is treated as a single individual unit of work. Either all the operation within the transaction are completed successfully or none of them. If any part of transaction fail, the entire transaction is rolled back to its original state, ensuring that data consistency and integrity and the database maintain in a consistent state. Okay, the things what we have to remember is do not occur partially. Okay, and it is also known as all or nothing rule. If all went success or no one, you can say if all or nothing. For example, transferring money from one account to the another account have two steps: debit and credit. Debit from account A and credit to account B. So this is the two activities which we are uh, performing with the help of transaction. Okay, as per the atomicity, either all debit and credit operations succeed or they will fail. Okay, like partial occurrence not allowed. Okay, let's see in our database. Here is a query. We are updating our database. Okay, we have two table, person and department. If we want to remove a department from our database and want to flag is deleted equal to 1, then we have to remove the person from person table where the department id is the same. Like department id 14 is there for arts and department id 14 is there for Kathy Amanda. Okay, so we have to perform two activities to achieve our goal. Okay, we are updating the department table is related is equal to 1, and then we are updating our person table. Okay, as is related is equal to 1. Okay, if both of the activities went successful, then yes, we'll commit the transaction, otherwise it will roll back to their original state. Okay, partial updation will not allow in our database. Okay, this is the concept under atomicity. The second one is consistency. Consistency checks are performed to maintain database constraints and business rules. Consistency enforcement prevent data corruption and invalid entries. Actually, we have constraint in our database. I will create a separate video on constraint and will attach with this video. So constraint help us uh, to use business rules to check the data what we are going to enter in our database. Okay, and other activities which help us to prevent data corruption and invalid entries. It ensures only valid record will be there in our database. Okay, used to maintain integrity of the table. For example, considering a database constraint that an account balance cannot drop below zero. Okay, in an account, yeah, the balance should be zero or greater than zero. Okay, negative value is not allowed. So this is the thing what we can prevent with the help of consistency. Okay, the third one is isolation ensure that multiple transactions can execute concurrently without interfering with each other. Each transaction must be isolated from other transaction. I will show this with the real queries in SQL Server. First, we'll go through the definition. Transaction occur independently without interference, preventing dirty read or lost data. Isolation maintain the independency of database transaction. For example, if transaction T1 update a row, transaction T2 must wait until T1 commit or roll back the changes. Isolation prevent transaction 2 T2 from reading unreliable data updated by T1 but not committed yet. Okay, let's check in our SQL Server. Okay, we have uh, a table person. Okay, let's remove this one. We have a table person. Okay, and we have three records in the person table. Okay, now what we are going to do, we are going to begin the transaction and try to update the city. Okay, if we'll run this one, okay, our we have opened the transaction and updated the column city. But same time, if anyone want to read the value from the same table, okay, what will be the output? We are not going to get any record because still the transaction is open. We have to roll back the changes or commit the changes in our database, then only other user can able to access. Okay, so we are doing rollback here and see we are getting the record for the other user. So this is the isolation means like dirty read or loss update will not be there. Okay, if transaction 1 updated the record, it has to be commit or rollback, then only T2 can perform their activity. And the last one is durability is a very common word. Okay, what it states, the transaction changes are saved to the database permanently and even if the system crashes. Durability is all about persistence. Once a transaction is committed, its changes are permanent and survive even in the face of system crisis or power failure. It means if once data is updated or saved in our database, it will be there for permanently. For example, if a transaction updates a customer contact number, durability ensure the updated contact number is not lost due to a hard disk failure or power outage. The changes will persist with the help of storage devices, backups, and logs. Video with your friends if you like this video. Thank you very much.